Make the most of it. Do whatever you can. Oh, I'm getting an error message for some reason. Everything seems to be working. I don't know what it's telling me. Oh, it's saying the system load is heavy. So we might have some choppy audio or jerky frozen video is what it's telling me. It's just saying right now there's a lot of people on Google Meet, I guess. I don't know if it's talking about my local system load like Bentonville schools or just Google in general. But that's interesting. I've never seen it give me a notice before. And it started like right after 7:15 because it's got a little graph for me that goes whoop way up here, like in between 7:15 and 7:16. So okay, guys. So if we get a little choppy video or audio, there's a heavy system load right now. All right, let's jump over and see what our lesson looks like. I've glanced at module 2 and we don't have a program this week, so that I knew that much at least. Let's go to the grade screen. Yeah, we're done with module 1. We're looking at, oh, it doesn't have the due dates up here. But we're just doing variables and functions, but I'll go back and check the due dates. Make sure those get put in place. But we're doing the first lesson, variables and functions. So let's go back and take a look to see. Close that folder. It's always good to close the folder. You feel like you're making progress that way. Variables and functions lesson. Okay. Working with variables. You won't get very far in programming without variables. They're a programming building block. We know that. Within a program, variables are reserved memory locations that store values or data that may change over time. So think of a variable like a reusable shopping bag. Both make it easy to store things, whether data or items. So let's take a look. So bags store items. So you can fill up bags with various items, kale, a bag of Doritos. There's more of a chance there's going to be a bag of Doritos in my bag than kale. I'll tell you. This makes items easier to carry. Variables store data. You can fill up a variable with data like numbers or strings. Declaring a variable to hold data makes it easier to work with throughout a program. So define main. This code creates a variable named food joke. So food joke equals what doesn't kill you makes you stronger. Okay, that's not that fun. Print the food joke. What doesn't kill you? So and kale may feel like it's killing you when you try to eat it. It really doesn't have much taste. I don't know. It's weird texture. Main. There you go. Food joke. So naming, variable naming. When you're creating variable names, make your life easy by ensuring they are descriptive and they make sense. And we talked about that a lot in programming 1, but here's a few do's and don'ts. All right, do. Begin variable names with a letter or an underscore. So, cart total or underscore shopping bag. We should not start them with like a number. It shouldn't be like 2 cart total or something. After the first letter, you can put numbers or additional letters. So just the first letter should not be a number. It should be a letter or an underscore. So transaction 1 is great. And of course, we should use camel case when a variable name contains 2 or more words or phrases. Item total, camel case capitalizes any additional words after the first one. We don't capitalize the first word, but item total, sales tax. That's it, camel case. Don'ts, because variable names may not be any of Python's keywords. And check out the reference section for example keywords to avoid. Reserve words already used, like print, if, all those lists, anything that's used as a Python command cannot be used. Main, main, we couldn't use main, like that. Variable names may not contain spaces. We know that. Not item space number. That'll give us an error. And cannot contain punctuation or special characters. Don't put an exclamation mark. Don't put an asterisk. Don't put an @ symbol. All of that will get us an error as well. But we've worked with that enough in programming 1. I don't think that's going to be an issue. Good reminders, though. Those reminders are always helpful. Fun with functions. Functions, sometimes they're called methods, so you may hear them called that instead. They're like smaller programs within your function. Like we define a main function, but we also had some programs last year. We defined other functions that did things, especially when we got into turtle graphics. We defined a function that draws a triangle or something. And when you call a function, they produce something like an instant camera produces a print, but you don't see a whole lot of those anymore. You've already worked with some built-in functions in Python, like print is a built-in function, input is a built-in function. But you can write your own functions as well. So let's say you want to define a function that will ask for a name and then print that name and say cheese. So the first step is defining that function and giving it a name. So let's roll over this parts of the code to see how to define the new function. Got to have that DEF, just like we use with define main. You know, we can define any function, defining some new function. Say cheese. So this is the name of our new function. So instead of main, it's called say cheese. And name is the parameters, which means when we run this function, we need to send it a name to use. So you put your parameters in parentheses. If you don't need any, like when we define main, we don't have any parameters, so we just put empty parentheses. And you may name a function anything you want, but it's best if the name reflects its purpose, right? Otherwise, you or others might forget exactly what it does, but if you name it well, you'll always know. So give your function its best name using these tips. Name your function something that reflects what it does, like define photo print, define checkout, right? And of course, use camel case again when it has two or more phrases. Define print total, define assign image with an underscore in there. That's another way to do without capitalizing. It's a different alternative to camel case is to assign underscore image instead of assign image with a capital I. But either of those work really well. Function names should not be random. Define dinglehopper. I wonder what a dinglehopper function might do. Hop around some dingles or so. I'm not sure. Define flapjack. I guess unless your program is making some pancakes, that's probably not a very good name either. Function names cannot contain punctuation or special characters. Say cheese, exclamation, at symbol, nothing like that. So it works a lot just like our variable names. Important many programming languages like Java or C++ require statements to be part of a special function called main. Oh, so that works a little differently with those languages. This is not required in Python. However, it is standard practice for Python programmers to define a main function, right? We said it last year, always have a main function. But why? Defining the main function helps add logical structure to the program. Structures it real nicely. The main function should include and call the main tasks that a program will perform. Like inside your main function, you would call these other functions that we define, but we know where the main part of the program is. So it's really good structure to have your main function. Efficiency is fun, parentheses. Functions are great at simplifying. So instead of running multiple lines of code every time you need to perform a certain task, you can just write that task once as a function and then call that function anytime you need it. Like we call that print functions all the time, but we didn't have to write a whole thing on how to print things because it's already defined for us. So in programming, getting rid of repetitive code is called deduplicating. Removing duplicating code. So deduplicating. That's a fun word to use. Try to use that in your normal life just once. That might be interesting. Take a look at the difference in code with and without functions. Try running the code below without the function in idle, and then try running the code with the function, and how do they compare? So that'll be interesting. We'll open up an idle window in a moment. Look at this, but with a function. So this program calls photo request 3 times. So the code in the photo request function is executed 3 times. So define photo request. So here's a function that has been declared. And inside the function, it prints first pick, second pick, third pick. Then we have our main function. And in our main function, it says call that function 3 times. Photo request and it doesn't send any parameters because it doesn't have anything it requires. Photo request, photo request. So this says this is the end of the program. Go ahead and run the main function. So it runs the main function and it's going to call this function 3 times. Over here, we have define main. So we don't have any other functions, just the main function. And we have 9 print functions. Print 9 times. Print first pick, second pick, third pick, first pick, second pick, third pick, first pick, second pick, third pick. And we end it and run our main function. So let's go ahead and open up an idle window just to have some fun with this. We're going to copy all of this code here. Yeah, let's see if it lets me copy. Let's put it in our Python window here. All right, so when we run it, there it is. First, second, third, first, second, third, first, second, third. Calling this function and running it 3 times. So now if we delete that, it's all gone. And let's move over to this side and copy all of this stuff. Copy. Same output, just without a function. So they had to keep typing the same commands over and over again. Print first pick, first pick, print first pick. They had to type that 3 times. Print second pick, had to type that 3 times. Had to keep calling, just manually doing the print statements over and over, instead of just calling the function 3 times. All in all, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code. Over here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines of code. So it did save a few lines of code with the function. All right, let's go to page 3. Variable scope and function. So variables can only be used where they are defined. This is called a variable scope. So when you create a function and add a variable that can be used within that function, it's called a local variable. So a variable defined inside of function can only be accessed if that function is executing. So that's good to know. So if we go inside and we create our own function and we define some variable in there, it can only be used when that function is running inside that function. Down in our main, we couldn't call that function and that variable, couldn't use that variable in a different function. So what happens when you declare a variable outside of the function? Then it's a global variable and it can be used anywhere. Right? It can be accessed by any function, the main function, other functions. So that's important. When you define a variable, do you need it just to be in that function, or do you need lots of different places to use it in your program? So let's take a look at the difference here. Local variables, how to use. You use by defining a variable inside of a function. This local variable will not affect the other variables outside the function, even if they have the same name. Oh, that's cool. So if you define a variable inside of a function, it could have the same name as a variable inside of another function, because it's just local to that function. This is extremely beneficial, and you should stick with local variables unless you have a good reason not to. So it's saying most of the time our variables should be local just for that function. But there could be some variables that need to be used throughout a program. With global variables, used by defining a variable outside of a function, so before your main function or other functions. Global variables are sometimes used for constant variables, but can make functions less portable since the variable is not located inside of the function calling it. So let's see how it looks. So this, you can put it in the main function and it's located in the function. So only the main function uses this. Froyo nearby equals look local, and then print froyo nearby. That's part of the main function. Over with the global one, before we start our main function, we have defined this. Froyo far equal look global. Froyo's nearby, froyo's far. But here, the main function could use this variable. Other functions you create could use this variable, and it would be able to print this anywhere. So when should we use a local one? When it's data that only need to be accessed within a function, we'd want to create a local variable. When you need more control over a variable, such as when and how it's used or calculated, choose a local variable. A global variable is when its data needs to be accessed throughout the entire program. More than one function needs to get, like it's an input statement maybe, and whatever they input, we're going to use over and over in different places. So we'd want that input to be outside of the function so that all functions have access to it. When you need to use a value repeatedly and pass it through multiple different functions, create a global variable. So here's the drawbacks. Unless you consider being faster and easier to debug a drawback, you'll usually be happy using local variables. So it's saying there's not a whole lot of drawbacks to using local variables. It's faster, it's easier to figure out when there's an error because it's going to be located within that function. If a program contained only global variables and there was a bad value, you'd have to skim through the entire program to find the variable that was causing the bug. Additionally, local variables release the memory when you finished with that function. The memory is released, so it runs faster. Global variables are always stored in the memory throughout the entire program, whether you need them or not. So, all right, so we didn't talk about this in programming 1. We're learning new about our variables, and perhaps there's a reason to put them outside your function. All right, variable scope in practice. Let's take a look at this code. Notice how the local variable is defined within local and outside global of the function world directions. Examine it, predict how you think this affects the output of the variable. Select output below to see if your prediction is correct, or you can try running it in idle. So let's just copy it and put it in idle. It's more fun to play with it in our programming window. So we'll go back to this, get rid of all that, put our new program in there, and let's take a look at it. Make it a little wider if we want to. Okay, hashtag global variable. So we've defined world map outside of a function, and so it equals global frozen yogurt store. So that can be used anywhere in our program now because it's been defined as global. Now we have a function called world directions. So the local variables hide global variables. So the world map here, same variable name, but inside this function, it will be the global store is too far away. That is the value of world map. And so when they print variable within the function, world map, it's going to print this instead of what it is everywhere else in the program. So in our main function, call the world directions function. It'll call the world directions function, and then it will do a print statement in the main function, which says this is the global variable. So we're going to print world map twice. We're going to print it once inside this function and once in the main function. And we've defined it as a global variable and a local variable. So when it runs the main function, the first thing we would expect would be it to print it as a part of this function, because that's the first thing in the main function, right? Other than the comment, first thing it's going to do is go up and run this. So we should say the global store is too far away first, and then without redefining anything, we're going to print the world map again. So let's run this. Variable within the function is the global store is too far away, but here's the global variable, global frozen yogurt store. So here's what's really cool is the first thing we did is we ran this function where it defines it as the global store is too far away. We did not have to go back and change it back, because up here we said it's global frozen yogurt store. After we changed it to this, we did not have to change it back. When we printed it, it automatically went back because this declaration only worked inside this function. If it's not inside that function, it's always equal to that first variable when it was defined. It's always this. But when it's inside the function, we can change it temporarily. But as soon as the function's over, it'll automatically revert back. That's pretty cool. That can be useful. That I just need to change it during this function, but the rest of the time I want it to equal what I already had it set at. That is pretty cool. Let's see. Output. Yeah, the global store is too far away. Global frozen yogurt store. So what's the bottom line with scope? Well, it freshens your breath, right? Oh no, that's a mouthwash called scope. I don't think they mean it. Always use the smallest scope possible for your variables. In other words, use the local scope and only use global variables when you really need to. Most of the time, they should be inside your functions, and that should be good enough. But there certainly could be cases where you need that global variable to be used throughout there. But global variables can make your program slower and make it a little harder when you have errors. Oh, we have a spotlight. Satoshi Nakamoto. I guess that's Satoshi. Satoshi Nakamoto, creator of cryptocurrency. In January 2009, the first Bitcoin software was released, marking the beginning of cryptocurrency. So cryptocurrency is 16 years old now. This type of digital currency is created through a program that uses encryption techniques to generate and verify funds. The programmer created this Bitcoin software by the pseudonym, so that's not his real name, his pseudonym is Satoshi Nakamoto. And they claim to live in Japan. It might not even be a Japanese person. It was a pseudonym. His Bitcoin software has made him one of the richest people in the world. In December of 2017, just 8 years afterward, Nakamoto's Bitcoin transaction log contained about 1 million Bitcoins, which is worth more than 19 billion US dollars. And that was in 2017. And Bitcoin has gone crazy since then. So who knows what it's worth today. So let's go to page 5. Page 5 just says, read the lesson, practice, and take the quiz. So let's look at our assignment then. Our assignment has 5 questions. When designing programs, good practice to find and reduce the amount of repetitive code. What's this called? Which of these is written in camel case? Which type of variables always stored in memory? Explain how you would define a variable named balance, assuming that the executing code has 4 functions which all need to use balance. And then your task is to write a function that finds the smallest number in a list of numbers. What's the best way to declare a temporary variable and why? So, well, we learned some good stuff in there. Local and global, the difference it makes in your program. And I can see where that can be really useful, knowing if I put it before my functions, then I can use it multiple times. But if I don't need to do that, I can create it and it's only good inside that function. So that's interesting. You know, if we create it inside of a function and then try to use it in the main function won't know what you're talking about. And that'd be an error that'd be hard to figure out if you didn't know the difference between local and global. You define your own function, you set some variable and you print it up there, and then you get down your main, you try to print it again, and it's like, what? Because, yeah, it was a local variable that only worked in that other function. So, something to play with there. So, all right, 5 questions this week, guys. Pretty straightforward, simple stuff, and we'll move on. I don't think we have a program next week either, if I remember. I think we've got a couple of week break here between programs. So have a great week, and we'll catch you next time.